Hi everyone, I'm Ansorge, a customer engineer in EMEA.
Hi, I'm Abhijeet Rajurkar, Solutions Lead for Data Management.
And welcome you back to the Technical Guide for Startups, where we are creating a series of videos for technical enablement to start, build and grow your businesses successfully and sustainably on Google Cloud. In our previous videos, we talked about how to scale with Cloud Spanner and how to optimize your cloud solutions for sustainability. And now we'll focus on our new database, AlloyDB.
In this video, we'll go through the database portfolio of Google Cloud and where we can place AlloyDB in it. We also get an overview of advantages of AlloyDB, talk about technical details of AlloyDB and why it is a unique offering from Google Cloud, understand the concept better by walking through a live demo, and lastly, we'll talk about a customer use case. So let's get started.
First up, we need to understand the available options that Google Cloud offers you to run your operational workloads. Every customer has different needs when it comes to choosing the suitable database solution. We need to think about what kind of data is stored, how and how often it is accessed, and how it will be used. We can see here that Google Cloud's portfolio covers different relational, NoSQL, and in-memory options to find the right fit for every use case. Let's dive a bit deeper into the relational options. Here we offer open source, commercial, and cloud-first databases. If you are migrating an existing app or if you are building a database with very specific needs that map to an open source solution, the first two are the right choice for you. If you are looking for a managed solution that is globally distributed and strongly consistent, you should have a look into the third option. Our newly added AlloyDB database combines the best of different worlds, so stay tuned and find out more in this video.
Let's talk about what makes AlloyDB so unique and why Google Cloud has added into its portfolio. As we have seen the acceleration of customers migrating their databases to the cloud, we at Google are constantly working on rethinking the technology they use. Our customers want to modernize from legacy proprietary services and standardize on open source. So we brought together all the benefits of the Postgres open source database with Google's innovation and created a database ready for all top-tier relational workload. And we call it AlloyDB. All this is done with preserving the functionalities and the benefits coming from most robust community proven by millions of users for the Postgres.
What are the main 6 points that we should keep in mind when deciding for AlloyDB? AlloyDB is Postgres compatible, supporting over 175 flags and 50 extensions, so you can move your existing apps without any code changes to AlloyDB. AlloyDB is also highly scalable and can scale horizontally up to 1000 virtual CPUs. That's about 20 nodes per AlloyDB cluster for read connections. This is also supported by the horizontal scale out of database optimized storage. The reason for migrating is easy. Our performance test in March 2022 showed that AlloyDB is 4 times faster than standard PostgreSQL for transactional workloads, thanks to the underlying caching and storage technology. But more about this later.
The high reliability and availability of 4 nines of SLA, including maintenance, gives you an unique advantage with AlloyDB. The database is able to detect and recover from most database failures within the span of 60 seconds. And this is regardless of size or the load on the instance. AlloyDB is also supported by multi-zone and multi-region architecture, which gives you almost seamless failover in case of your region or the zone fails. Thanks to AlloyDB's non-disruptive management operation, the resizing and maintenance can be also done without much disruptions to the end users. AlloyDB is also highly scalable and can scale horizontally up to more than 1000 virtual CPUs for read connections. This is also supported by the horizontal scale-out of the database optimized storage. We have seen in our test that AlloyDB is up to 100 times faster for analytical queries compared to a standard stock Postgres, thanks to its columnar execution engine. This engine leverages the technology for faster scans, joins, and aggregations. this columnar engine is very easy to use as there is no schema or application change needed whatsoever. We automatically populate the column store using machine learning to understand your evolving query patterns and continuously optimize the performance of your AlloyDB database.
Let's think about advanced machine learning. AlloyDB can support you here through its autopilot systems, helping with automatic memory management, automatic vacuum management, which is one of the biggest problems in Postgres, and storage tiering across multiple layers, and therefore ensuring a great price-performance balance on diverse workloads. It also has the Index Advisor feature that can be used to recommend indexes for your database by analyzing the most frequent queries and improving the database for their performance. Last but not least, we offer transparent and predictable pricing. There are no license fees or opaque I/O charges, and you only pay for the storage that you are using. So if you drop a table, you can see the price going down straight away. Now, let's go a bit deeper and discuss the technical details of AlloyDB, which makes it a unique cloud-native database.
Most customers today run databases on general-purpose storage that is not specifically designed for PostgreSQL and therefore not optimized for its performance. With AlloyDB, you get a storage which is optimized to run database workloads. A key concept of AlloyDB is disaggregation of compute and storage. This concept previously available on expensive proprietary databases. The storage is separated from the compute node and has its own intelligent software designed to improve database performance and reliability. Underlying AlloyDB is Google's massively distributed scalable file system called Colossus. The same system that is used for billions of user applications like YouTube and Gmail, and also behind our database Spanner. The storage scales horizontally and automatically. When a YouTube video goes viral and suddenly millions of users viewing it, does the owner of the video need to tune the database to support the workload? Do you need to shut down the database to repartition the storage? No, the performance just hop and scaling just happens out of the box. And that's what we have bought into AlloyDB storage. Why should we and PostgreSQL database be different? As your transaction volume increases and your storage needs increases, the scaling and performance just happens. You do not need to reallocate storage or repartition your tables. You only pay for storage what you use. You do not need to perform the complex storage tuning or partitioning to get the performance.
The design of AlloyDB under the covers is quite different from other databases. In the distributed storage system is a high-performance, synchronously replicated, append-only logging system. Transactions from the primary service are logged to the system and written in a storage subsystem to a secondary compute node in another zone asynchronously. There is also asynchronous replication to up to 20 read replicas, providing for horizontal read scale-out. The database can be recovered directly from the logs, eliminating the need for any checkpoints and performance delays when the checkpoints occur. I/O bottlenecks are automatically eliminated. One of the key improvements in AlloyDB is that the checkpoint is not done in the database tier, but is moved to the storage. A key to high performance is multi-layers of caching. AlloyDB provides caching on multiple layers. First, in-memory and SSD caching with the storage system. Second, an automatically attached SSD cache to each compute node, called the ultra-fast cache. The customer gets the benefit of SSD caching at no additional cost and without custom configuration. Third, the in-memory buffer caching provided by Postgres. Fourth, an in-memory columnar engine which dramatically speeds up analytics. Only AlloyDB offers this feature in the Postgres world. This columnar engine is an in-memory store that is automatically maintained by AlloyDB. The customer can turn the feature on or off and can manually configure which columns are included. When a SQL query is performed in AlloyDB, the query optimizer automatically determines if the data is in the columnar store. If so, it uses advanced algorithms to eliminate scans on range searches to significantly reduce the number of CPU instructions required to perform the query. If some data is in the store and some is not, the optimizer automatically scans the data where it is stored. You always get a consistent, correct answer that includes all data committed to the database. In-memory columnar stores provide extremely fast analytics. With AlloyDB, you get the strength of both worlds: fast, reliable performance for operational transactions and extremely fast analytics on operational data. With the columnar engine, you may be able to drop indexes on tables that were used for analytics. With fewer indexes, transaction-wide performance is improved. Column store queries use far less CPUs than queries that scan the buffer, cache, or storage. You may be able to get by fewer virtual CPUs, which may cost you less, as AlloyDB charges by the virtual CPU.
Let's have a closer look at the columnar engine and why it makes analytical queries so fast from technical perspective. AlloyDB uses columns metadata and columnar filter to accelerate the query processing. Its machine learning models are learning from both the content of the column and the type of query operations that are getting executed. Learn metadata is used both to encode the data values efficiently and to accelerate the query processing. For example, when a string column that has a small number of distinct values is used in filters, the columnar engine may decide to generate a list of distinct values as metadata. This then can be used to accelerate both equality and range-based filters. Faster scans, faster joins, and faster aggregations are achieved through different techniques. The faster scans are decided using columns metadata that can store the list of values for low cardinality columns, minimum and maximum values, which helps in column filtering. AlloyDB uses Bloom filters to make table joins faster. If the join column have high selectivity, AlloyDB uses the power of vectorized filtering. This means filtering on a column of data that is stored in a vector to reduce the number of rows that needs to be processed by the join operation. For optimizing query performance, AlloyDB provides the maximum query performance when using highly selective filters on wide tables or when joining tables with high selectivity. And last but not the least, we have the vectorized operations for the faster aggregations. AlloyDB can directly perform vectorized aggregation operations on the columns. This means that it can perform operations like sum, average, and on columns data without having to materialize the entire result set. This can improve performance significantly, especially for large data sets.
A selective filter is a filter that only considers a subset of the rows in a table and is therefore using inequality predicted. For example, a query that looks for all customers who live in Paris is a selective filter because it only considers the rows in a table that contain the customer's location information. A less selective filter would use wider row scans and would therefore need more query time. A highly selective join is a join condition that only returns a small number of rows. Joins on tables that are highly selective can be up to 10 times faster, as AlloyDB will use Bloom filters, whereas join on tables that are less selective can be 2 to 5 times faster in columnar scans, if that's chosen. The AlloyDB Query Planner uses a costing model to automatically choose the best mode of execution for each node in the query plan. It can either choose a columnar scan or a traditional row format sequential scan or even a hybrid scan. In the demo, we are showing you how a query performs way faster compared to a normal Postgres instance on AlloyDB. This will give you an idea about how you can leverage the in-memory columnar store on AlloyDB. This caters to your needs of having a HTAP database.
In this demo, we are going to show you how a query performs way faster compared to a normal Postgres instance on AlloyDB using its columnar engine. This will give you an idea about how you can leverage the in-memory columnar store of AlloyDB in your day-to-day workloads. This perfectly fits in your needs of having an edge tab database. I have logged into Google Cloud Console. When you browse through the data management section, you can see AlloyDB listed here. For this demo, I have pre-created an AlloyDB instance and loaded some data into it using pgbench, a standard benchmarking tool for Postgres. And I have also added a read replica for the AlloyDB instance. Here, I have created a read replica with the flag columnar engine set to on. So if you compare the two instances of AlloyDB, the primary and the read replica, the CPU shape and size is exactly same. The only difference between these two is the columnar engine flag. On the primary, there is no such flag, and on the read replica, you can see the value is set to enabled. What we will do is we will execute a query, exactly same query on the primary as well as the read replica, and see when the data is coming from columnar engine, what is the query performance you are getting compared to executing on a normal Postgres. If you click on the data protection tab on left hand side, that is the place where you can configure your backups either in a continuous fashion, which will help you to do a PRTR up to 35 days, or you can have the backups as per your on-demand requirements of the organization. We also have a tab on monitoring, which will give you insights like CPU, memory, and utilization and IOs. For our demo purpose, let's connect to the primary and see what is the data there, how many tables are there, what is the volume we are executing the query against. So let's connect to the primary. As you're on the screen, you can see that I am connected to the primary instance. There is no flag enabled. I can show you the tables. Here are the tables into the schema. Let me show you the number of records in it. Here are the number of records in this table. Now let's execute a simple query on this table and see how it performs. Before executing, I'll just enable the timing so that we know how much time it took to execute. Fantastic. Now we know the time it took on this primary instance. Now let's go to the read replica where we have enabled the columnar engine and execute the exact same query and see the difference in the timing. One interesting to note here is AlloyDB can create read replicas with its own columnar cache. So that means you can use your different read replicas with a different columnar cache, serve a purpose of different departmental queries. So here I am connected to the read replica. I just made this screen as a brown so that let's not confuse with the white screen which we used for our primary. Now you can see the exact number of same tables. Here you can see exact number of same records in that table. Now let's execute the same query with setting the timing on. Boom. The query is out already. So you can see it's not only 100 times faster, but it's much more than that. Let me show you the value on the white screen, and here is the value of brown screen. And you can see there is much more difference how performant the query was with the AlloyDB's columnar engine. I'm sure you want to try this feature and see the impact on your queries. So go ahead and spin an AlloyDB instance on Google Cloud.
You have seen the powerful columnar cache demo. Now, let's see how our customers find it. Here are some of our customer references. How a Brazilian beauty tech startup, B4N, transformed their business with AlloyDB. As B4N is growing, it faced the challenge of scalability in their database, as queries took seconds to complete. By integrating AlloyDB in its core technology platform, B4N was able to reduce their query time by 90%. This means from 12 seconds down to 1.2. integrate a fully managed service that resulted in time and effort saved on managing the infrastructure and setting up and configuring the database. And last but not least, they were able to cut their costs, as in AlloyDB, you only charge for what you use, and there are no traditional license fees.
We will like to close with this slide. With AlloyDB now, Google Cloud is the preferred and best home to run your PostgreSQL workloads. You can run and fully manage vanilla Postgres instance on Cloud SQL. If you need an enterprise class features of Postgres, then AlloyDB. And if you need a global scale with finance of availability, Spanner with the Postgres interface is the answer.
Want to find out more? Check out our guides and documentation. You can find some links in the descriptions. And get your data moved to AlloyDB. We're looking forward to hearing your success stories. We'll see you very soon in our next video, where we'll cover how to architect a blockchain startup. Thank you for joining us today in this episode. To continue exploring AlloyDB, check out the links in the description. Don't forget to like this video and subscribe to our YouTube channel, and click on the bell icon to get notified each time we post a new video. We hope you are as excited as we are to get on board with this journey. Hang tight and we'll see you very soon on the other side.